Salutations to the person or people that are going to be watching this. Today's tutorial is going to be on proving sum and difference identities. So let's go straight into it. So here I present the 4 trigonometric identities I'm going to prove. So I'm pretty much going to start with proving cosine A minus B equals cosine A times cosine B plus sine A times sine B. So we're going to start with angle B, and which is going to be referred to as point B, and its ordered pairs are cosine B, comma sine B, and also included point D, well, angle D, and it's going to refer to as point D, which has an ordered pair of 1, comma 0. And our second angle A, which is going to be referred to as point A to make it easier, and its ordered pair is cosine A, comma sine A. So both angles in the unit circle, it creates a third angle, which is angle A minus B, and it's going to be referred to as point C, and has the ordered pairs of cosine A minus B, comma sine A minus B. So on how all this plays out, each angle has an opposite angle. Like, for example, point C's angle is the opposite of point D's angle, and it creates a distance between C and D right here. Same thing goes for point A's angle. The opposite would be point B's angle, and it creates a distance between them, which, creates a distance between them. Okay, from what we saw from the unit circle, the two distances are equal because they're all the same length and on the unit circle. So points C and D are, all points C, D, A, B are A minus B away from each other. Because, point C's angle and point B's angle are just A minus B away, because that's what makes the third angle A minus B. So C and D, C is A minus B. It's just the angles A minus B. And then point D's angle is just 0. So it's just A minus B away, if that makes any sense or so. Well, anyways, moving on. I utilize the distance formula, which is the square root of x1 minus x2 quantity squared plus y1 minus y2 quantity squared. And I just inputted the ordered pairs from the unit circle into the distance formula. So right here I put cosine A minus cosine B, which is the corresponding of, x values of A and B. So cosine A's is the x value in angle A's, while angle B's x value is cosine B. So just inputted it in there. Same thing goes for sine. The y1 minus y2, I just inputted their y values into there. And same thing on the other side. I just inputted the x values and y values from point C's angle and point D's angle, which is just cosine A minus B and just 1. So those are the x values, and then y values is going to be sine A minus B and 0. So it's just substituting into the distance formula, so it's pretty easy. Anyways, how I got rid of this rad 2, the only way to get rid of a square root is to use the inverse, which is square. So we just did the distance square equals distance square, and then it cancels out the square root, and we're just left with cosine A minus cosine B quantity squared plus sine A minus sine B quantity squared equals cosine A minus B minus 1 quantity squared plus sine A minus B minus 0 quantity squared. So this is where it gets well, a little, well, not a little, a lot of work. So we're like climbing up the mountain and so we're gonna start on the left side. So all we're going to do is just distribute. So cosine A minus cosine B, I just expanded it into cosine A minus cosine B times cosine A minus cosine B, and distributed, and we get cosine square A minus cosine A cosine B times cosine B minus cosine A times cosine B plus cosine square B. And just to save time, well, did the exact same thing, just distributed different values and got something similar to that, which is sine square A and so and so. So yeah. So I just distributed and combined like terms and ended up getting cosine square A plus sine square A equals 2 times cosine A times cosine B plus sine A times sine B plus cosine square B plus sine square B. So I pretty much organized it so it wouldn't look so messy. So in order to get 2 minus 2 times cosine A times cosine B plus sine A times sine B, I just used Pythagorean identity. And Pythagorean identity is just cosine square x plus sine square x, which equals 1. So that's what I did here, just played with the values and created something easier to work with. So cosine squared plus sine square A is going to be 1. So, and then we're just left with this value. And then at the back we have cosine square B plus sine square B, and again we just create it into 1. So we just add these two, which is 1 1, and it becomes 2, and we're just left with 2 cosine A cosine times cosine B plus sine A times B. Wow, crazy. Anyways, since we have the left side all finished up, we move on to the right side, which is cosine A minus B minus, well, they're in parentheses, minus 1 quantity square plus sine parentheses A minus B minus 0 quantity square. So I did the same thing again. It's just distributing. I just expanded it pretty much, and just to fast forward and not to like go through all this unnecessary work, but sometimes it's necessary for the person depending if they need the details. So where am I? I'm going to be left with cosine square parentheses A minus B parentheses plus sine square parentheses A minus B parentheses minus 2 cosine parentheses A minus B plus 1. Wow, I need water after this. Okay, anyways, so I just got the two values I got on both sides, which is going to be 2 minus 2 cosine A times cosine B plus sine A times sine B. And then on the other side, meanwhile, we have 2 minus 2 cosine A minus B. So I just simplified it from up here and then just went straight into work. And overall, well, you end up with the, proving cosine A minus B equals cosine A times cosine B plus sine A times sine B. So all you have to do is just subtract the 2 and divide -2, and then that's pretty much it. I proved one out of the 4 trigonometric identities. Oh boy. So from the long journey we had going uphill and this whole shenanigan of trying to prove the trigonometric identities, all we have to do is find the other 3, and from what we got earlier, which is cosine parentheses A minus B parentheses equals cosine A times cosine B plus sine A times sine B. So with that, we're just going to replace B with positive B with negative B. So we could get its counterpart, cosine parentheses a plus b. So all we do is just substitute all the positive b's with replace all the positive b's with negative b's. So we're gonna be left with this equation of cosine parentheses a minus negative b parentheses equals cosine a times cosine negative b plus sine a times sine negative b. So with that, well, pretty much, all we do is multiply a minus sign times a negative. So on the left side, it's going to be cosine A plus B. So we already have our sum on that side. But on the right side, it's kind of, well, it's somewhat tricky, but not really on how I see it. So on the right side, we're going to have cosine A and cosine B. And just keep in mind that cosine is an even function, so cosine negative b would equal cosine b. And on the other side, which is sine, we're gonna have minus sine a, plus sine a times sine negative b. So on that side, sine is an odd function, so sine b would become sine negative b would become sine b, but the catch will be creating the plus sign into a negative. So it's pretty much they switch, sort of, and which creates this sum of the equation. So you're going to be left with cosine a plus b equals cosine a times cosine b minus sine a times sine b. So that's 2 out of 4 trigonometric identities. So it continues to be easy. Well, this continues to be going downhill from here. So anyways, in order to convert cosine to sine, we're going to use cofunctional identities. So cosine, according to the cofunctional identities, cosine parentheses pi over 2 minus x parentheses equals sine x. Same thing goes for sine over sine parentheses pi over 2 minus x parentheses equals cosine x. So if we apply that to this situation right here, in order to convert cosine, we're going to have to use cofunctional identities. So we're going to input cosine parentheses pi over 2 minus a plus b and so forth with the others. So when we convert all the identities, all the cosine identities into sine, we're going to be left with sine parentheses a minus b equals sine a times cosine b minus cosine a times sine b. So it's just pretty much converting them all. So we have the third trigonometric identity, and just like last time with cosine being converted into, minus to positive? Plus? I don't know, but, it gets converted to, plus to minus, so-and-so. So right here, we have minus. So we're going to convert it like last time into plus. So we're going to replace b with negative b in each of the angles. So I just inputted all the negative b's into where they originally were, where the positive b's were. So we have sine a minus negative b equals sine a times cosine negative b minus cosine a times sine negative b. So just like last time, we're just gonna just solve it somewhat. So we're gonna have sine parentheses a plus b parentheses equals sine a times cosine b plus cosine a times sine b. So how we did it last time, cosine is like an even function, so cosine negative b is gonna equal cosine b. Just like last time, sine negative b is gonna be sine b, but the catch is we're gonna be switching the values. So instead of being a minus, it's gonna be plus. Instead of this being a negative, it's going to be a positive. And so we have our final trigonometric identity. So, yeah, that's it. We got all our identities proven. Hopefully that wasn't too confusing for the audience. I don't know. That concludes our tutorial.